Hi everybody, this is Mrs. Ellsworth. What we've talked about so far are the different types of energy, and now we'll be talking about the different forms of energy, which is a little bit different than the types of energy because they can both be working in the same type of situations. So like mechanical energy can occur during when it's in motion, like kinetic energy, or when it's sitting there and there'd be stored, it would be potential energy. So these are the different forms of energy as where we've talked about the different types of energy before. We do not have any formulas that we need to worry about with these ones, like we did with kinetic energy and potential energy. So let's talk about the first one of these ones, mechanical energy. Okay, when we're talking about mechanical energy, what we're talking about is things that have parts that move. And when these parts move, then it's mechanical energy while it's in a kinetic state, but the whole thing is that the energy is due to the motion of these objects. Your body has got mechanical energy because it's got moving parts that can move. Same with your car, your bicycle. Anyway, in this case right here, this bowling ball has mechanical energy. It's moving down the lane. It's got, in that case, it's got kinetic energy. You can figure out that amount of energy. When the ball hits the pins, that kinetic energy and mechanical energy from that bowling ball transfers right straight to those pins. Here's some more examples of mechanical energy. This guy has got moving parts. Same with Mike Phelps there. Your bicycle has moving parts. All of that whole system of that roller coaster has got moving parts. Okay, what is electromagnetic energy? That's our next one. Okay, an example of that electromagnetic is the whole electromagnetic spectrum that comes from the sun. And I'll list those here in just a minute. But this has got several different types of rays that comes from it. Now your phone has also got some light coming from it too. And electromagnetic means electro means electricity, and magnetic means of course magnetic. But those are the types of waves that comes from the sun. Here's more examples of it. The electromagnetic waves that come from a microwave tower. Okay, your phone has also got some infrared waves too. Anyway, so when we're talking about this light energy, it includes all of these different forms. Gamma rays, it goes through your body, completely through it. Okay, even through your home. And X-rays that go through parts of your tissue of your body too. Ultraviolet rays actually goes through layers of your skin too. It actually can burn your skin, can it? And then if you turn down the frequency more of those electromagnetic waves, you can get visible light. Slower waves yet would be infrared rays, microwaves, radio band like your FM radio that you listen to in your car. Those things are all different types of light energy that come from the electromagnetic spectrum from our sun. Let's talk about electrical energy. Now this is all about the movement of electrons. When you've got electrons moving inside those wires, you're talking about electricity that can occur and that it runs so many of our products that we have in our home. Anyway, so those electrons, they run through the different power lines that convert to different forms of energy in your home. Can you imagine if you had a fan plugged in your home that is plugged in, and so it's getting electrons moving through it, and that actually changes forms inside the fan to mechanical energy that turns those blades, and that little motor turns those blades and creates some breeze on your face. So it can be changed in different forms. If you go and you plug it in and then you get visible light from a light source, that's changing from electrical energy then to light energy. So when we talk about forms of energy, again, it can switch from one form to another. We call that energy transfer. And we've talked about so far mechanical energy, light energy, or electromagnetic energy, and also electrical energy. Now we'll talk about chemical energy. Now chemical energy that is there in a type of situation like the gasoline in my car tank is sitting there, and as soon as it is running and it is going and putting the gasoline into the different cylinders of the car and firing and moving those pistons, it's got all those moving parts going. That chemical reaction occurs when the gasoline is lit. That chemical energy creates other types of energy. It changes from one form to the next, and it moves parts inside of my car. Anyway, chemical energy can come also from food, from a matchstick also. That energy is being transformed into heat or thermal energy and also light. You can also think about spaghetti. That is definitely chemical energy. It's sitting right there ready to be ate so that my body can go and use it, create chemical reactions, and I can get some energy from it. Power plants use coal. Of course, batteries also have energy inside of them too. So those are different types of chemical energy that we can tap and utilize that energy and then change it into a different form. Here's another one, thermal energy. Now, thermal energy is talking pretty much about heat energy, okay? And so that means when those atoms are excited that they create a lot of energy, they create a lot of heat, and so that the more that the atoms are moving around, the more heat that they produce. So hot objects, those molecules or atoms are moving very excited, very fast. Cooler ones, they move less fast. They're going slow. Okay, now let's talk about all these different types of energy and do a little quiz here. So quiz yourself. Okay, what form of energy cooks food in a microwave oven? That would be electromagnetic energy, because that's one of those different forms of light energy. And electromagnetic waves was one of the ones that we had listed on there. Okay, what about that plate inside? Okay, it's spinning, it's moving around. So what type of energy is that? That'd be mechanical energy, because it's got moving parts, it's moving. Of course, it's in the kinetic phase or kinetic type if it's moving. Okay, let's have another quiz here. Here we've got this electrical outlet. Okay. Okay, what type? Okay, so electrical energy is transported to your home through the power lines. Okay, when you plug an electric fan in the power outlet, the electrical energy is transformed into what form of energy? Spoiler alert, I accidentally ruined this from before. It would actually be mechanical energy, because now you got moving parts. Okay, what about if that plug-in instead it got a lamp to go? Do you remember what we said that would be? It would be like light energy. What's the other form for light energy? Electromagnetic energy. Okay, now in this situation here, this guy, he is trying to push this big heavy crate or box. So what type of energy is shown there? This is actually kind of a trick question, because there's more than one type of form of energy there. He's pushing it, he's got moving parts, things are moving, the box is moving away from the, with the body or whatever, and so that'll be mechanical energy. And then there's also thermal energy, so don't forget that too. Okay, here is a picture of a tree. Okay, what type of energy is happening there? Well, I suppose that you could say this chemical energy. If you could cut that up, you could actually have energy to light a fire. Also, photosynthesis is going on too, which that is a chemical reaction. So there's definitely chemical energy going on here with a living plant like a tree. Okay, here we go. We've got now a remote control turning on a TV. So what type of energy is this? There's more than one type of energy. There's several forms of energy. First of all, think about your fingers moving. So what type of energy would that be? Okay, it's actually turning on a TV. So what type of energy is that? What's going on there? Okay, and also when you push that button down, it makes electrons move inside the remote control too. Okay, then what transfers that energy from the remote control to the TV? Well, that would be infrared rays. They're electromagnetic waves. So electrical, mechanical, and electromagnetic. What forms of energy are in some food? I bet you guessed it right. It would be chemical energy. Okay, here's another quiz question. What form of energy is shown below? This is a hot source on your stove. It's got so much resistance to the electrons moving through it that it's, so you've got some electrical energy, but what other kind of energy is going on there? Heat would be thermal energy. Okay, I want you to think about Next, I want you to think about 5 different forms of energy that a car has. Pause it, write down 5 different forms, just thinking about it. Pause. Okay, coming back to this. Here is a battery that's in a car. So we're going to look at a unique way of looking at this. Okay, so when we think about that, we've got electrical energy coming from that, right? And in one case, it actually sparks and it starts moving different parts in our cars. Okay, so that would go and create some mechanical energy over here. Oh, and I should have mentioned that there's also thermal energy because there's heat coming off. Okay, and then up here in this one, we're talking about starting a radio. Okay, and so a radio has got electrons moving through it, so that's definitely electrical energy, but then now it makes sound. And sound is nothing more than a making waves in the air, so it's mechanical energy, actually sound energy is. That's pretty cool looking at it that way. Okay, and then electrical energy, we can use it to start all kinds of lights in our car. What type of energy is light energy? Electromagnetic. Okay, so there's just 3, and I asked you to find 5 on that car, so let's talk about 2 more that you could talk about in the classroom. Okay, now we have just one last thing that we need to be talking about, and that's the conservation of energy. When you go and smack a cue ball into a whole set of billiard balls, the whole thing is that it transfers all that energy. If you hit it harder, it even transfers more energy, and you have more ball play going on here. If you don't hit it very hard, then not too much happens, does it? But it's saying that the energy can transfer from the cue ball to the other balls, okay? And it is saying that we're not getting that energy to move all those balls from just anywhere. We're getting it from that cue ball. So it's saying that it can't be created nor can it be destroyed. It just changes from one form to the next. So if you think the energy is disappearing, usually there's a reason for that, and usually it's caused by friction and that we're losing energy in a different way, and so it's creating heat somewhere else in it. But there's definitely never a change in energy. There's never a loss of energy that you can't find the energy somewhere. We don't create it or destroy it. It actually just changes forms. Okay. What I want to talk about quickly, I'd be remiss if I did not talk about renewable and non-renewable resources of energy. Now, the non-renewable resources like burning wood, burning coal, and these things are not made by Earth near fast enough for our consumption rate. Now, nuclear power plants, there's very few that are being made recently. There's been several made in the 70s, but not much since then. There's right now one being made in Atlanta, Georgia, but they were having a problem because it's already costing them $28 million to build. They're only halfway through it. They're completely out of all their money for it, so they're going to have to refund it. And it costs a lot of money to make them, but they do not create the waste that the other forms of energy does. They do not create quite a carbon footprint on our society and on Earth and for any type of greenhouse gases such as the other non-renewable sources. Let's quickly look at one more thing here, the different types of renewable resources, and I think that we're going to go and take some time and look into these individually in different groups. But biomass is using organic material that we have and creating energy from it. Hydroelectric, of course, is using turbines inside the water to create energy from rivers or from the ocean tides. Solar, so whether it's heating up water or if it's charging up a battery. Wind generation, I know in 8th grade trip you guys all went and saw wind generators from the inside. Hydrogen fuel cells is becoming something quite unique over more in the California areas. There aren't too many for hydrogen cell stations anywhere around here. Geothermal power is where you're taking heat energy from the underneath the Earth's surface to use that energy, harness it, and use it in another way. And nuclear fusion is a clean way of using nuclear power. And so we'll be discussing these in much more greater detail in projects in our class. And I will see you next time.